All right, so we're gonna do the last two problems of this chapter. So read the problem. It says, what is the mass in kilograms of 173,231 liters of jet fuel, whose density is 0.738 grams per mil? All right, so don't get overwhelmed. All you say is, okay, what am I looking for? Same process every time. What am I looking for? So I'm looking for the mass. So I want the mass, and it says in kilograms. So I want the mass in kilograms. Okay. And then we say, okay, well, what did you give me? You gave me this number. It's a liter, and so a liter is a type of volume. You could write your volume if you want to write it. You could just write the number. If you don't even know what it is, just write the number down. And then they gave me this number, but it tells me it's a density, so then I have the density. Now you could use density is equal to mass over volume and do it that way, but I want to show you how you do it with without the equation, with just the units. So I got to start somewhere. Got two numbers. He's got 1 unit, he's got 2 units. So he's simpler, so I'm going to start with him. 173,231 liters. Okay. I have liters. I want kilograms. Got liters, I want kilograms. So then I said, okay, I've already used this. Do I have anything that relates liters to kilograms? This guy has milliliters and grams. Well, kilogram, gram, that's close. Milliliter, liter, that's close. So I can use this, but I gotta do a little conversion before. So I can't go directly from liters to kilograms. So before I can go from this volume to this mass, using this guy, I need these units to match up. So I need to go from liters to milliliters first. So if I'm trying to get rid of liters, he goes on the bottom. Milliliters go on top. The only difference between a milliliter and a liter is the little m, the milli. So I go to my prefix table. Whoop, went too far. Milli. Little baby m. Make sure you don't confuse it with mega. It's a little m. Little m, milli, little m is 10 to the negative 3. Okay? 10 to the negative 3. So then I said, well, where does it go? Does the 10 go here or here? If my prefix is here, it always goes on the opposite side. So the prefix is on top, the 10 goes on the bottom. So this is 10 to the negative 3 on the opposite side, and this is 1. So my liters cancel. All right, now I have milliliters. I want kilograms. So now at least I've got this unit matched up. So I say, okay, now I can use this guy. But I'm not going to be able to go directly to kilograms. I'm only going to be able to go to grams with this guy. So I have milliliters. I want them to go away. Milliliters have to go on the bottom for them to go away. I'm not going to go directly to kilograms because here it's only milliliters and grams. So in this guy, I can only go from milliliters to grams. Okay? So now I have my units. Milliliters will cancel. I could go to grams. I need the thing that relates. I need these numbers. So what relates grams and milliliters? This guy. So remember, this is saying 0.738 grams per milliliter, per 1 milliliter. So the 0.738 goes with the gram. So the 0.738 is going to go with the gram. It's going to go on top. And then this is 1. It's always an understood 1. We just don't write it. So it goes on the bottom. So 0.738 grams, 1 milliliter. Milliliters cancel. Now I have grams. I don't want grams. I want kilograms. So I need my grams to go away, and I need my kilograms on top. Okay? What's the only difference between a gram and a kilogram? The little prefix. Go to my prefix chart. Oop, pass it up again. Kilo is little baby k. It stands for 10 to the third. Okay? So kilo is 10 to the third. So then, where does it go? Top or bottom? If the K is on top, the prefix is here, but 10 has to go on the opposite side, always. This is the biggest mistake. Prefix on top, 10 goes on the bottom, so it's 10 to the third. Grams cancel, all I have left is kilograms. So I have the correct units. So now I do the math. 173,231 times 1 times 0.738 times 1 divided by 10 to the negative 3 times 10 to the 3. That's in a parentheses, that's in a parentheses. I do the math, and my answer is going to be 1.28 times 10 to the 5th kilograms. You want to write this stuff in scientific notation. If you're not used to scientific notation, you need to practice that, because we're going to do a lot of scientific notation in this class. All right, last problem, our last one for this chapter. So this says find the density in grams per centimeters cubed of a metal cylinder with mass of 8.3 grams, length 1.94 centimeters, and radius 0.55 centimeters. The volume is equal to pi r squared L. All right, so that's a lot. So don't become overwhelmed, don't freak out, just say, what am I looking for? So it says find the density. Okay, so I'm looking for density. Here, let me do a little question mark. Find in the density, or you can write D, and it's in grams per centimeters cubed. All right, now I write what they gave me. So they gave me the mass. They gave me the length, which is L. They gave me the radius, R. And I just write like, oh, they gave me this equation. All right, so usually we say, okay, well, which one's the simplest? Well, that, and that are all the same, so where do I start? So if they're all kind of the same simple, and we already have an equation, this should be the big sign. Oh, there's an equation, so I'll probably use the equation. But let's think about what we're looking for. We're looking for density. So we don't have to know the density equation, remember? We don't have to know, we just look at the units. So I need to find density, which is a gram and a centimeters cubed. So then I think, okay, do I have a gram? I actually do. All right, those match. I need a centimeters cubed. I don't have that, I have a bunch of these. Okay, I know density is related to mass and volume, so let me look at this guy. So this guy is pi, which is on your calculator, r squared and L. R is the radius, L is the length. So when I notice this, I go, wait, I have an R and an L. I need this to be cubed. These are just centimeters. So let's just think about what would happen. If I plug this in to this, it's going to square this unit. So that would be a centimeter squared. When I plug this in, then I'd have a centimeter squared times a centimeter, which would give me a centimeters cubed. All right, so maybe I should use this equation. So let's see what happens. So volume is equal to pi. Let me put my radius in. Let me put my length in. All right, I need to simplify it. Let me get rid of that exponent. So let me square the 0.55. So that gives me 0.3025 centimeters squared. You also, you square the number and the unit. So I squared the number, gave me 0.3025, squared the unit, give me centimeters squared. Now multiply. Pi, use the button on your calculator. There's the pi button on your calculator, use that, times this guy, times this guy. When you do the numbers, you get 1.84364. A centimeter squared by a centimeter. Remember, like units, when you square, they just combine and kind of increase. So a centimeter times a centimeter squared times a centimeters cubed. If I did a centimeter squared times a centimeter squared, that'd be centimeters to the fourth. You just add up the exponents. All right, so now I got this. So I look, I say gram, gram. Centimeters cubed, centimeters cubed. I don't even have to know the equation. Just the units are telling me to take this guy and divide by this guy, which is the mass divided by the volume, which matches my understanding of density. But if I forgot which one was on top, volume or mass, this kind of helps me, the units. So to find the density It's grams over centimeters cubed is what I'm looking for. My grams was 8.3 and my volume was 1.84364. Okay, do the math. 8.3 divided by 1.8 gives you 4.50 grams divided by centimeters cubed. Okay, so this is how you work out these problems. So on your homework, your second part of your homework for this chapter, you have nothing but conversions. Conversions is going to be very, very important because we're going to be using volumes, we're going to be using mass, we're going to be using densities, we're going to be using all these different types of measurements in this whole semester of chemistry and even into the spring. And so what you need to be able to do is you need to do these basic conversions. This is kind of like the foundation of chemistry, is to be able to convert things. Temperature units, mass units, whatever it is, okay? So if you're struggling with this, you want to come see me so I can help you with this. But there's a lot of conversions. That's why your second homework is nothing but conversions to help you be able to practice doing these. All right? So that's it for this chapter. So finish up your assignments, and then you'll get to start on chapter 1, which now we get to start talking about what the atom looks like, the periodic table, and kind of a little bit of a history lesson on chemistry and the background of chemistry. All right. See you later.